All right, number 10. The answer is somewhere. Clearly it's, well, actually, I don't know. Yeah, number 10 is yes. Because one pair of opposite sides is parallel and congruent. You're coming to class or what, bud? That depends. Number 12. The answer is no. None of the tests for parallelogram are fulfilled in number 12. Number 14. The answer is no. Because because they don't have, none of the tests are fulfilled. Number 16 is proof. We can probably look at that one in a minute. Number 18 is x equals 2 and y equals 29. Let's go. Number 20 is x equals 30 and y equals 15.5. Number 22 is x equals 40 and y equals 20. Number 24 is, hold on. That one's going to be a graph, right? What is it? What are we doing? Graph the quadrilateral? Yeah, number 24 is we'll look at it if you feel like we need it. Same with number 26. And then number 28 is,
will you tell us the answer?
it's a graph, and I can certainly show it to you if you need it. But as of this moment, I'm not, but I can in a minute. Where was I? Number 30 is also a proof. Look at all the proofs I gave you. Number 32 is a proof, and number 36, the answer is for y is a minus b and c, and the answer for x is a 0. What questions do y'all have? 36. 30, 32, and 34. Okay. The proofs, huh? Except one of them. Sounds like there was one that you got fine, yeah? Wasn't there one other proof?
Yeah, 16.
Number 16. Got that one. That one was easy peasy.
I just didn't know how to start it based on how they asked to do it.
Okay. Because it said do prove the theorem. Yeah. So you'd have to go back in the book to see which one they're even talking about. Would be the first step. Very, very first step, because we didn't number them that way. So the very first step for number 30, we're doing a 2-column proof, not a paragraph proof, right? Of theorem 6.10. So what is theorem 6.10?
Theorem 6.10.
Mm-hmm. It's on the same page as 6.9, as theorem 6.9.
I don't see it.
It's like there's like a whole little table of theorems.
Oh, it says, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram.
So, we are given what all are we given in that theorem, essentially? What is in the hypothesis part of that theorem?
If both of the pairs are opposite, then they're going to be congruent.
Okay, so we're given that the opposite pairs are congruent, right? We're also given that it's a quadrilateral, so it's 4 sides, right? Which may or may not be useful, but we're given quadrilateral. We'll label it A, B, C, D so that we can do something with it, right? quadrilateral ABCD, and we are also given that angle B is congruent to angle D, and we're given that angle A is congruent to angle C, and then what are we supposed to prove? What is the conclusion part of that theorem?
Angle B is congruent to what?
Angle B is congruent to angle D.
Oh, okay.
It does kind of look like an O. My chunky pen makes straight lines with harsh angles kind of difficult to write. Because he's a chunky boy. What are we trying to prove? What's the conclusion part of that theorem? If what, then what? Yeah, then. So we're supposed to prove that quadrilateral ABCD is a parallelogram. Probably better write that out because that looks confusing at that point, huh? Is it a parallel? Is that right? Yeah. Parallelogram. Yeah. Does that make sense? Again, you won't have any that are specifically like that on the test where it says prove Blake theorem. It'll actually give you the given and the stuff and all the all those things. And you'll be able to use these theorems if they're given as well. Which means theoretically that if I give you a proof on the test, it'll be a really easy one. So let's walk through this one since we've got it, and I know most, if not all of you, haven't tried it yet, right? Because even Kendall didn't try it yet. Yeah, that's fine. Okay, this is a lot like the one we did in class the other day.
16.
What? This is number 30. Oh, this isn't number 6. Oh, yeah. Well, did you get lost on that?
I attempted it. I was going to use some sort of side angle side.
Yeah, probably on 16 you would use something like that. I didn't look closely at it, but I suspect that's true.
And then I was like, wait a minute. How would I use side angle side?
This is not the right one. So we would, of course, do our givens as step 1. Got to at least get those points, right? What else could we do? When we're trying to prove that a quadrilateral is a parallelogram, what are we trying to prove ultimately?
That they have two pairs of parallel sides.
Yeah, so we need to prove that AB is parallel to DC and AD is parallel to BC. So, what could we say?
We could use our given that B is congruent to D and A is congruent to C to do something along the lines of, I'm formulating words. Hold on.
The inverse, is that what it's called? The thing where you like switch it and then be like angle D is congruent to angle B instead.
Oh, so like the transitive property? We may end up using that at some point. Look at you, remembering things. Good job. Virtual high five.
Can we use that the measures of angle A and angle D equal to 180 between the two lines?
So almost, I think we're going to head there. We can't actually say that they're 180 yet because we don't know that, but we can say something with the angles. What do we know because it's a quadrilateral? They equal 360. We could definitely say that. That the measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D equals 360. Because interior angle of a polygon okay. So what else could we say? Now how can we use our given with that?
Angle B and angle D equals 180.
Not quite, but we're headed there. That is where we're going. But we got to do something. We got to do something with these guys. We got 4 variables. Can we clean that up and make it about less variables?
You can erase
We could just erase them, and the justification would be strange magic. Yes. Okay.
Let's go with that.
Let's go with that.
Can we turn them into like segments, like A, B, B, and C, or the other way around?
I'm not following you. I'm not saying you're wrong. I'm just not following what you're saying.
I have a question.
Good.
Well, it's random, but
I know.
okay. You're recording this, right?
I am today, yes.
Does that mean that they can hear us?
Probably a little.
Okay.
Fun. Yeah. It'll be on YouTube. You can go listen to yourself. Could I say, oh, no, not that. That's a bad idea. Could I say that the measure of angle A plus the measure of angle B plus the measure of angle A plus the measure of angle B equals 360? What is my justification? How did I say that? Substitution. That's right. Now what could I say?
The 180 thing?
We're headed there. What?
Still not there though?
We're about to be because of algebra.
The thing where you switch it?
A plus B equals 180?
That is where we're going, but how do we get there? If we had, so what we have here, we rewrite this, right, in just like regular things. X plus Y plus X plus Y equals 360. What can we do over on this left side to clean it up?
You subtract, or you add all the x's first.
Yeah, combine like terms and add the X's first. Yeah, all those words.
2x plus 2y.
2x plus 2y equals 360. We could factor a 2 out. We're actually going to skip this step in our proof. Right? And then what would you do? That would make it back. If I want to get rid of that 2, I would divide it by 2. You would get the same answer, but not in context, it's not the same thing. So we can get,
So what would you write?
so for this part, we're right now we're here, right? We can go straight to here. What justification lets us get from here to here?
Algebraic equation.
Kinda. How about substitution? Because this equals that. So we're substituting the one for the other. When essentially once we get in these in geometry, right, unless we're doing algebraic proofs, which are a different beast altogether, if we're just doing algebra, probably the justification is substitution, probably. Except the next step, because it's not substitution. But it's okay. So we've got the measure of angle A, 2 times the measure of angle A plus the measure of angle B equals 360 because substitution. So when we divide it by 2, what lets us do that? I'll give you a hint. It's basically what it sounds like it is. Division property of equality. That's right. If we want to be really technical, but the way I grade proofs, we're not going to stress about it. If you want to be really technical, you'd have to say that it was 360 divided by 2, and then you'd have to say 360 divided by 2 is 180 because substitution, but let's not worry about that. We'll let that one be because common sense. You can't actually write it, but you can imply it. Division property of equality. Right? What can we say because of that? That's right. We can. You did them right too. Good job. So proud. If only we could say they were congruent as well, then we could just be done. But no. What is it? AD? Yes, AD is parallel to DC. What lets us say that? Converse of, technically, since we're saying that they're parallel, right? The converse of the same side interior angle theorem. Beautiful. Okay. So we just proved that this is parallel to this. How would we, I don't think we have to take the time to do it in here. What would we do to do the other two?
Substitute D for B.
Yeah, do the other way around. You'd basically repeat all these steps, but with the other letters. That's right. And then when you have that they're parallel, then you can say that it's parallelogram because the definition of parallelogram. That's right. So, what about 32? So 6.11. So what is going to be our given on number 32?
If the diagonals are quadrilateral bisect each other, then the quadrilateral is a parallelogram.
Okay, so that's what it says, but what is our given then? What is the hypothesis part of that? That's right.
And then we're going to prove that the quadrilateral is a parallelogram.
So we've got the quadrilateral ABCD again. That totally is a quadrilateral. It's not a bunch of squiggles.
Looks like half of a square.
And it was half a square,
Looks like a square and then like a triangle if you drew a line through it.
I guess. The diagonals bisect each other. Is that what you said?
Yeah, I think.
Okay, so our given then,
Bisect each other.
we need one more letter, right? How about Q? Why not?
Because Q's an ugly letter, that's why.
Speaking of Q, I haven't caught up watching the latest season of Picard. Oh well, I will eventually.
Huh? How did that relate to that?
You'd know if you knew.
Yeah, I would, yeah.
Yeah. Okay. So remember that we're technically kind of skipping a step to say this, but what we're going to say that it says is that AQ and QC are congruent.
That's our given?
Oops. That's one half of it. And then we can also say that DQ and QB are congruent as well. That's what bisecting tells us. And we're trying to prove the same thing. We're probably going to go for, on this one, I would think you would go use one of the other, try to prove that the opposite sides are congruent by like CPCTC or something. I think. What do y'all think? Wonder what they did. Let's look. Let's look, shall we? What is this, number 32?
Yes.
What is this? This is lesson what? 3. Number 32. Congruent. Yeah, that is what they did. Okay. Yep. Okay, so, because I'm not seeing any other way to do it. So how could we go about this? We need to start proving triangles are congruent.
Say that AQB is congruent to DQC.
Yep, and we can do the same thing for these. I agree.
Could we do anything with DQ plus QB equals DB?
You could, but remember, if we're going for proving triangles congruent in this, then we probably all we need to do is get SSS, SAS, SSA, right? So we could do segment addition. You've got that one solid, but it probably wouldn't help.
So, and then we couldn't do anything with the reflexive property either.
Your two favorites.
Yeah, my two favorites.
No. So the not measure, but angle A Q B is congruent to angle C. I did. QB And we'll go ahead and since it's the same justification, we'll use the same deal that AQD is congruent to angle CQ. Wait, I did something wrong. Oh, I know where it is. Y'all see what I did wrong?
It's a C and a C.
The C and the C should be right. That's not what's wrong. Well, yeah, that was wrong because I stopped in the middle of writing a letter. One of these letters on this one is wrong. It should have been CQD is what I was trying to write.
Okay, I was gonna say,
And so then this will be CQB. Okay? Because why? Vertical angles. Now what can we say?
I was just writing convertible angles.
Convertible. We're going to use side angle side to say what two things? Yep, those triangles. Triangle AQB is congruent to OI.
is congruent to what?
Triangle CQD. And triangle AQD is congruent to triangle CQB because side angle side. Now what can we say? Yep. CPCTC, yes. Congruent parts of congruent triangles are congruent. CPCTC. There's a C in between everything. Congruent parts of congruent triangles. AB is congruent to DC and AD is congruent to BC because of CPCTC. Last thing we can say is that they're it's parallelogram because opposite sides are parallel, right?
What does it mean? Congruent parts of
Con-
congruent triangle congruent?
Are congruent.
Okay. What does SAS mean?
Side angle side. It's a proof. There are 4 or 5 proofs of congruence. One of them is side, side, side. So if all 3 sides are congruent, then they're congruent. The other one is side angle side. A side, another side, and they're conjoined angles. Then the 2 triangles are congruent. The other one is angle, angle side. So if we have an angle and a side on 2 triangles, then they're congruent. And angle, side, angles, yes. I knew there was at least 4. Angle, side, angle. So if we have an angle and the congruent side, then the triangle's congruent. Proofs of triangle congruency. Don't take a nap. But ASS is not a proof of congruence. Because, ew. That's not really why, but It makes for a fun way to remember it.
Because you write that down under proof. Justification is because you.
No, that would be a lack of proof because it's not a proof of congruence. Okay. Makes sense. Good to go. Did we get 36? I thought 36 might be tricky, but I didn't know for sure.
That's the answer?
Yeah, there's one more step, but yes. One more step would be that because opposite sides are congruent.
Are we gonna write it down?
What?
Are we gonna write it down?
No.
Why not?
I mean, you can. It's your homework. This is me helping you.
Because
Yeah. You would if you were taking a quiz or a test. Or if you were doing it on your own on your homework. But now we're trying to move on. So we did fine on 36. I'm not hearing any questions on 36. I figured that one might cause some issues, but
Let's just go over it anyways.
do we need to go over it? We're not going to waste our time. We ain't got time to waste. Did you say no? That's what you said? All right, let's look at the next lesson. Rectangles. Everybody's second favorite shape. Think so? What's your favorite shape? Triangles are the strongest shape. That is true. Well, strongest two-dimensional shape. You know what is something that is absurdly strong is an egg.
An egg?
Eggs are super, super strong.
But we
Eggs,
drop them?
depending on your philosophy, eggs are either an amazing feat of evolution or an amazing feat of creation or both. Eggs are incredible.
I would say both. They probably adapted over time.
Yeah.
It's really,
Did I not say both?
well, I would say like combination.
Ah. Yeah.
One of the 4 criteria for life is to have the ability to adapt and change. So
Yeah. Those are generally speaking the 3 ways of viewing the origin of the universe. Evolution, creation, or both.
why do you think it's like extremely strong? Like I'm not following.
It's not a thought, it's a proven fact. Okay.
Okay, so why
What
is
is
that
the
your
reasoning
statement?
behind that fact?
What?
What is the reasoning behind the fact that you think an egg is actually strong because it has?
Oh, eggs? I thought we were talking about triangles.
No.
It's a testable hypothesis. You know what the easiest way to test eggs, the strength of an egg, is to take an egg and hot glue, or not hot glue, but it'll stay better. Hot glue bottle caps on either end of it, set it on a table, and see how many textbooks you can stack on top of that egg before it breaks.
Really?
It will astonish you because they're very strong.
I know what I'm doing.
Tensile strength,
But how come when you drop them they break?
because they're not strong that way. Because of course they're not. If they were strong all the ways, then the baby wouldn't escape. And we would never have any more baby birds or reptiles or whatever.
How many textbooks were you able to stack?
I don't know. You should try it. You should film it.
I need to have an explanation. Well, I guess.
It's because he's never actually done it.
No, it's not wise because I'm a teacher and I expect you to learn things. Okay.
I need to have an explanation for my mom walking in like, what are you doing?
My math teacher said,
Yeah, my math teacher told me to do it.
stick an egg. You know, it's also a fun experiment. It takes a lot longer though. Is if you take an egg and stick it in white vinegar for a long, long time. That's a fun experiment to do.
We had to do it for that class.
And what happens?
It got all soft and squishy.
Yeah, they also, if you leave it in there long enough, the eggs also expand.
Yeah.
How was that fun?
It
It's
was
interesting.
a blast.
Party over there.
It's a party over there. No, it's just science. What am I writing?
Biology.
Rectangles. I don't like biology. Stamp collecting.
Me neither.
I just don't
I like physical sciences. Physical sciences, there's lots of fun.
I like PTA.
PTA, physical therapy
It's just
assistant program. That's not a class, it's a program.
Well, I like it
You do? How do you know you like it?
because I've watched people do it.
You watch people do it. You are interested in it. that what you want to do when you get big?
I can't tell you how
When I
many
get
people.
big.
I can't tell you how many people watch blacksmithing and said that looks really fun. I bet I'd.
Okay.
And they do it.
What is the definition of a rectangle?
Well, it's a shape.
What page are
It
you
is a what category does it live within? What's its super? It's a quadrilateral, but it's also a what?
on? A square.
It's also a parallelogram. Yeah. It's not always a square. A square is always a rectangle, but a rectangle isn't always a square. True facts. Okay. So it is a parallelogram. In which all of these things are true. What has to be true for something to be a rectangle? Has to have 4 right angles. What's true about the opposite sides? This is true of a parallelogram as well. You could, I guess really that's really it. We don't need to write that. We just wrote all that. Because everything else is just true of a parallelogram. It's a parallelogram with 4 right angles. So, our machine,
Not that interesting.
they can be very interesting. They are a more constrained parallelogram. Machine, don't make me hate you today. Okay. That's what I thought.
You're talking to your computer?
Possibly the pen. I don't know for sure which.
Whichever's not complying with them.
Yeah. You don't ever talk to your computers? What's wrong with you?
I talk to my phone.
Okay, yeah.
Well,
And your phone even talks back.
Well, I don't talk to Siri.
my
Don't talk to Siri. Hate that girl.
set up like there's a thing called Cortana in Windows 10.
Mine is
Cortana doesn't really exist anymore.
No, she doesn't. But what she did, I renamed it to where she responds to computer. And so I just walk in my room and be like, computer, play Hippies in the Cowboys by Cody Jinks. It was awesome.
Why would you say that?
I wish I
Because it's a good song.
Is it? If a parallelogram it's going to be garbage.
Okay, I'm so excited for it.
I'm just kidding. It might be great. Who knows?
What is it?
A Halo TV show. Is it Paramount? Who's putting it? Paramount? Yeah.
Like with the video game?
That's exactly what she said. That's funny. Parallelogram is a rectangle. They've been trying to make an adaptation for a long time.
It's of the video game?
The what?
They're making a TV show based off of a video game?
They've made lots of TV shows based off of video games.
Which video game? I'm so lost.
One of the best TV shows of all time recently was made from a video game.
Which TV show?
If parallelogram is a rectangle,
I knew it.
then
If we knew, we know.
if you knew, you know, yeah. It was on Netflix, I'll tell you that much.
You know how many
Then
shows are on Netflix?
it's
Outer Banks.
that was not based on a video game.
Outer Banks? Oh my god.
The video game is garbage, but the show is really good. Then it's Diagonals.
Can you really not tell us what the show is?
I gave you all the information you need. I said recent Netflix based on a video game. You could figure it out from there.
Series or a movie?
Series.
Some of us live under a rock.
Recent.
Wait, is it a movie or a series?
Netflix.
Then it's Diagonals
Is it animated or
are
live action?
animated. Congruent.
It's congruent.
No. Then I don't know
Is it
what it
animated
is.
or live action? It's congruent.
But if you're one of those people that are like, I don't watch animated shows, you should still give it a chance because you might actually like it.
Shows, and I think it's really weird. He loves cartoons.
There are some cartoons that are not very they're not very kiddie.
Oh,
This one is one of those. Okay, so there you go. There's your theorem. Makes sense? So far, so bueno? Yes, good?
Hold on.
Why?
Because
They're like scratch and sniff stickers. I love it so much.
I will show it down parallel.
it's a good case too.
The converse of this theorem is also true. What would be the converse of this theorem? That's not the...
I was keeping.
What would the converse of this one be?
If a parallelogram, if a parallelogram or whatever is not a rectangle.
That's the inverse, where you negate them. If the diagonals of a parallelogram are congruent, then what?
Oh, those little lines aren't L's, they're parallel.
Yeah. You're getting it. She's getting there. Then it is a what? A rectangle. It's a quadrilateral. If, well, yeah, but you didn't need to see all that. If you could just say, if a shape is a parallelogram, then it is a quadrilateral.
That's why I said an
Elogram.
so
So confuzzled. Now, which example or examples do we want to do?
Of the action? What's that box word?
I think we're going to go off grid and I'm going to write an example.
Oh, a rectangle.
Let's hope for the best.
Instigator?
Okay. Here is our shape. You ready? Well,
There's a snake.
that'd be great, but I don't know. After I discovered the exit, I'm a little bit concerned.
The exit of what?
But I don't know. We'll see.
I'm so lost.
It's okay. You're allowed to be lost. You don't want to meet the snake anyway.
There's a snake?
In my boots.
Well, you don't even wear boots.
Not often, but I do some. I don't need lies. Don't need lies on top of lies. I would like a really nice pair of dress boots, but I don't have that kind of money right now for that kind of frivolous item.
For the kind of what? Frivolous?
Frivolous.
Word of the day.
Okay.
I'm so tired from the time.
So, if the measure of AC equals x minus 3 and I was about to write something dumb.
Oh, yeah?
This is why I don't usually write geometry problems, because it's too much to think about to not make something dumb. At least not, I do write them, just not live. If the measure, let's do, yeah, I think this should be doable. We'll see. Of QB equals
I think we're lost.
I haven't written the problem yet. Calm down.
You're taking a little.
I don't want to write a problem that's not solvable. This is why I don't usually write geometry problems, because they're not easy to make just without actually doing a little math and sanity checking yourself. Measure of QB equals, let's say,
This is literally the problem we did earlier, but we proved that it was
2x minus 20. Solve for x. I think that's theoretically possible. Let's see what happens. All right. So, what are we going to do to solve this guy?
BQ is half of AC.
The measure of B or Q. B equals half the measure of AC. It's absolutely true. So what now? Plug them in. 2x minus 20 equals 1/2 times x minus 3. Then we're going to solve for x. So what should we do? Distribute the 1/2. Bring down 2x minus 20 equals 1/2 of x minus 3/2. Then what?
Then you're going to subtract the 2x.
Sure.
Or
Two.
you can subtract the 1/2.
Either one would get us the right answer. I'm going to go ahead and add 20 as well, since we're going that direction. Those cancel and those cancel, leaving us with just 0. What's 1/2 x minus 2x?
1.5.
Negative.
Yeah.
Negative 3/2 x plus what?
1.5.
Don't think so. Signs are different.
You have to do 20 plus 3/2.
Subtract.
Oh. Negative 3/2 plus 20.
Yeah.
I was trying to talk to Siri, but she wasn't listening.
Oh. Thought you didn't talk to Siri.
I
Siri's
knew you were
always
gonna say that.
18 and a
18 and
half.
a half. Then we can subtract 18 and a half from both sides. Those cancel, leaving us with negative 18. I'm going to rewrite that as a mixed number. As an improper fraction, which would be negative, what is that, 36, 37 halves? Does that sound right? Come on, Mr. Mental Math. Then we can multiply both sides by negative 2/3. And we end up with x equals 37 thirds. That sound right to everybody? Okay, it's time to assign you some homework. How's that sound? Great?
Fantastic.
Fan-flippin-tastic. I'm not going to give you any proofs today. You're welcome.
Bless your soul.
What?
I said, bless your soul.
Bless my soul. No, you're in the South, girl. Bless your heart. Bless your heart, which can mean all kinds of terrible things. And often does. Homework, page 426, numbers 10 through 18 evens.
That is not a lot.
It's not a lot, but you can handle it. Just make sure to write down and remember all the right ones.
Well, no, 5
It's because you only did something for this lesson for 10 minutes.
What?